Okay, good afternoon. So you guys have this sheet in front of you, and this video will explain to you how to do your assignment. So first off, if you haven't put your name on your paper, go ahead, put your first and last name. I'm going to walk you through this assignment so you can get an easy A. If you pay attention, it should be pretty simple. Um, I'm not there to answer questions, so please pay attention as I go through this. So as we look at this, yesterday we talked about what's inside of a nucleus. We said a nucleus has three parts: of protons, electrons, and the neutrons. We then said the protons are found inside of your nucleus, with the neutrons and electrons on the outside. So as we do this assignment here, we're looking at part number one. So it says draw 5 protons. So there are two ways to do this. You can actually draw the plus signs. To make it simple, I simply say, well, I need 5. 1 second. So I'm writing 5 and a plus sign, or I can write 5 and a P sign. Both of mean the same thing. They're indicating that I have 5 protons in the nucleus. So that's number one done. Okay. So draw 5 protons. Number two, say draw 6 neutrons. I could draw 6 circles there, but at the same time, I simply do a 6 and an N. So now I have 5 protons and 6 neutrons. Keeping in mind that your numbers of protons and neutrons are not always the same. Number 1 and 2 are done. Let's do number 3. Draw 2 electrons. So my electrons are on the outside. So I can indicate this with a negative sign or with X. In this case, I'm going to do an X to keep life simple. 1 and 2. And number 3 is done. So I'm indicating that they're on the outside. They have a negative charge. Number 4 says draw 3 electrons at the second energy level. So we have 1, 2, and a 3. Keeping in mind that only 2 electrons can fit. Now, if you were able to look at the periodic table, you will see that there's only one element that has 5 electrons, and the element would be boron. So keeping in mind that your atomic number, okay, your atomic number is a unique number that only one element has. As you can see, 5, 6, 7, 8, 9, 10. There are no two elements have the same atomic number. And so if you look at that, the answer for this one here would be boron. And so we know that if we use our periodic table, that the element that has 5 protons, okay, and 5 electrons would be boron. So yesterday in class, we looked at how to read this. So here would be your atomic number. And once again, I'm giving you answers for the first part of your assignment. So write it in, please. This would be a symbol. And for this one here, if it's an O, we know it's oxygen. This would be the name of the element. And this would be its atomic mass. I'm going to write atomic mass there. So the question is, what does your atomic mass represent? If you remember from yesterday, we said your atomic mass represents the number of protons. That's what it means. Now, it so happens the number of your protons, which carry a positive charge, is generally always going to be equal to the number of your electrons, which carry a negative charge. Okay? And what does your mass represent? Well, your mass represents your protons plus, and plus means you're adding them together, plus your neutrons. Okay? So, I've actually given you answers for 1 through 7. Now, number 9 and 10, I'm going to let you do on your own, but I'm going to show you how to do the second part of your assignment, number 11. So, if you look at our periodic table, and you find lithium, you will see that lithium has the atomic number 3. And if you don't look, they tell you. So you gotta know your atomic number means protons. So right away, I can say, hey, my number of protons here would be 3. Why? Because these two numbers must be the same. Okay? They have to be the same. We then said up here that your electron number will always be equal to your proton number. So I can go right ahead and say this number and this number must be the same. If that's a 3, then that must be a 3. That's how easy life can be sometimes. Now, the question is, what is my neutron number? If my number of protons plus my neutrons, okay, so these work together. If these two together equals this, if I'm telling you you have 3 protons, You got 3 protons. Then therefore I can say 7 minus 3 will give you 4. In other words, if I have 7 apples and oranges, 3 of my fruits are apples. I am telling you 3 are apples. Therefore, how many of them are oranges? You'd simply subtract and I would get 4. Okay? So that would be your answer for that one. Now let's flip it. I'm going to do this one and nickel. Ni for nickel. If my atomic number is 28, how many protons do I have? The smart ones, you already said it must be 28 because they must be the same. If my protons are 28, then my electrons must also be 28. Life is just that good. Now, I'm telling you here that I have 28 apples called protons and 31 oranges called neutrons. How much fruits do I have together? This time you're not going to minus, you're simply going to add. And then, so you do the math and put those answers in here. So that's your first part of your sheet. The second part deals with how to draw what's called your Bohr models. The first thing you have to understand is how much electrons can hold. So they can only hold 2 in the first shell, 8 in the second shell, and 18 in the third shell. So here's your answer for number 12. Number 13 should be in your notes. We covered this yesterday, so look it up. So how do we draw our models? Well, we do the same thing we said earlier. Sulfur has an atomic number of 16. If I know that, I therefore know this, and I must know this, because they're going to be the same. So 16 protons, 16 electrons, and if we do the math here, we're lucky enough that there's also 16 neutrons. Okay, so that's the first part of your answer. The second part is to draw all electrons. So we're not drawing protons or neutrons. We're only drawing our electrons. Okay, so I'm going to circle my electron number because that's the one I want. According to what I just told you, you must follow your 2, 8, and 18 orbital alignment. So of this 16, how much can hold in the first shell? Only 2. That shell is now full. But I need to have 16. How much can hold in my second shell? Well, I can hold 8. So I'm going to draw 8 up here. 1, 2, 3, 4, 5, 6, 7, 8. So now I have 2 plus 8 is 10. So now I have 10 electrons, but I need 16. Therefore, I'm going to put 6 in my outer shell. 2, 4, 6. This would be the correct Bohr modeling or Bohr diagram of how to draw this particular element. So all we're going to do is take our electrons and fit them in to these various shells, following the rule, only 2 in the first, 8 in the second, and 18 in the third. Now, if you have less than 18, you're only putting the number you have. Okay? So you're simply saying, hey, whatever this number is, I got to fit it into these shells. Okay? Following the rule that 2 in the first, 8 in the second, and if you need any more, up to 18 in the third. So when you get done, you should have this number of electrons, this number, and this number drawn in here following this rule. So that's how you'll do this. On this sheet, you're not to do 16, so you can put an X over it, or just don't answer it. That's all you have to do. So I hope I clearly explained this to you guys. If you are still lost, make sure you ask the teacher to rewind it so you can go back and look over it. So at any point in time, you can go back and have that rewinded to the point that you were lost and get it. So this is your first assignment. There's a second assignment Ms. Lewis left for you to be completed. I just wanted to explain this one to you because I know there could have been some issues and some of you can be confused. Have a good day and behave yourselves.